Hey there, this is Christine. Thanks for tuning into my Mostly Keto Kitchen today. What I'd like to do today is present another research article that looks at fructose versus glucose. So as a reminder, if you're looking at fructose versus glucose, you're essentially looking at the difference between sucrose versus starch. And that's because sucrose is a fructose plus a glucose, and starch is just a glucose. So really the key difference here is that fructose. And just a reminder, sucrose is just another way of saying table sugar. All right, and so why I want to tell you about this is, for one reason, is that the article that I'm going to talk about is really well done, and so I'd like to share some of the data with you. And then the other thing I'd like to do is just reiterate this point, and that is that sugar is not just empty calories, right? There's forces in the industry out there that would like to have you think that sugar's not such a big deal, you can go ahead and have it with a balanced diet, and especially if you exercise, it'll be fine. However, I want this, what I'm going to show today is just more information to let you know that sugar changes our biochemistry, and for some of us that's an issue, and actually I think for the majority of us that's an issue. There are a few people out there that are okay with eating fairly high sugar. It doesn't seem to damage them, but for most people this is a serious issue. So the way the study worked is, so it was published in 2009, and there were 23 authors, and so that's a lot of authors, and they were all from various California institutes, so universities and hospitals, and it was probably pretty intensive in order to carry it out the way that they did. Now, I will put a reference for the article in the description, and so what they ended up doing is taking 32 overweight people, and they first put them in an inpatient environment where they could feed them a particular diet, and they could get a bunch of baseline values. So that way they could look and see how things changed as a function of the diet that they were going to put them on. So then, so that was for 2 weeks, and then it goes for 8 weeks where they are allowed to go home and just eat like they normally do, but they're going to have either a fructose drink or a glucose drink that they have to have every day. And so they ate at how they wanted to, so it's called ad libitum, and they ate as, so as they wanted to. And after that 8-week period, they came back into the inpatient facility, and they were continued to take the drink that either had the high fructose or the high glucose in it, and then but they also had a very set diet, and at that point they started doing some measurements on them. So so having that inpatient part is a very controlled setting, and that's important because you can't really trust people and what they've been eating, and so people often are not very good about reporting back on what they eat. So that's a really important part of the study, that they had that inpatient piece. It's also what they call double blind, and that is that the researchers didn't know who was on the high fructose part or the high glucose part, and neither did the participants, so they didn't know which sweet drink that they were getting. So anyway, a lot of good things about this article. So in the end, they all gained some weight, all right? So whether you were on high fructose or high glucose, people gained weight. And it was not a lot. Remember, this is only 8 weeks, so about 4 pounds is what they gained. However, interestingly, people on the high fructose diet, they increased their visceral fat by a lot, by about 4 times. Okay, so much more visceral fat. And remember, that's the fat that's in and around the organs, and it's an indication that your metabolism isn't working quite right. So, so that happened, and then in addition, people on the high fructose diet, their triglycerides increased, and also the small dense LDL particles increased, and there were some other changes. These things that I have here in blue, I'd like to address in another video in the future. So what I'm going to focus on more for today is the increase in insulin that they observed, and also the decrease in glucose uptake and usage. So, all right, let's take a look at the first graph. So in this graph, we have over on the left-hand side, we've got the glucose change as a function of first at the 0-week mark, and so that's after that baseline has been established, and then 9 weeks into having the increased amount of glucose drink. And here you see that there's no increase in the amount of insulin over that time period, so insulin stays the same. On the right-hand side of the graph, that's where you notice what happens when people had the high fructose drink. And here you see insulin increases a lot. Okay, so this is consistent with what I showed in a previous video comparing a high starch diet to a high sucrose diet. In that case too, it looked like fructose augmented the response that you would normally get from eating some glucose. Now, this was done with what's called an oral glucose tolerance test. And so the way they do that is they fast a person, so just like overnight, they don't eat. And then the first thing that they do in the morning is have a glucose drink. And then the researchers measure the amount of insulin and glucose as a function of time for, say, the next 4 hours or so. And that way you can see how much insulin is getting released as a function of having had that glucose drink. So clearly the people that had the high fructose diet, they have a different insulin response, an increased insulin response because of having been on that fructose diet. Now, what's significant about this, if we remember back, insulin is the storage hormone, right? So that is the hormone that says, oh, we've had enough to eat. Let's just go ahead and store this stuff away for a day when maybe we don't have enough food. Now, with the weight gain difference and where it went, what this means is that the storage was happening in the places around the organs, and that is not how we're supposed to store our fat. We're supposed to store fat if we have, a period of feast, we're going to store it away, but not in places that are going to be on top of, right where our organs are. We would want to have more of a subcutaneous fat storage, and apparently that's more what was observed with the high glucose drink group versus the high fructose drink group. Okay, so now let's look at the next graph, and this one here is a bar chart showing glucose versus fructose, again, week 0, week 9, and this is using a different type of test called a glucose disposal test. And so the idea here is that they can use a labeled hydrogen, so that's with a little H2 over on the y-axis, sort of little 2 that's a superscript there. That means deuterium, and that's a hydrogen with an extra neutron associated with it. It's not radioactive, but it's a tracer. And so the people were fed glucose that had that deuterium on it, and then the question is, where did those hydrogens end up? They're the deuteriums. Where did they end up, and did they get used like they were supposed to be used? And so you'll see that glucose, people fed the glucose drink from 0 to 9, no real difference in their disposal of the glucose from the glucose test. Now, the people that were fed the fructose diet, those folks, they have a difference in how the glucose, the deuterated glucose that they were fed, is used up. And that is actually a 17% drop in their ability to dispose of the glucose. So what that means is that they're not using their glucose like they're supposed to. So it's like a double whammy here. They've got increased insulin, which should put more glucose into the cells, but what we're seeing is that the glucose is not getting into the cells and getting used like it's supposed to. And that right there, that's what diabetes is about. And so it's almost like the cells are starving because they're not getting the glucose that they need. And meanwhile, glucose levels are rising higher and higher in the blood. And then that's going to cause glycation, and the glucoses are going to get attached to proteins and start mucking up the protein function. So clearly, there are biochemistry changes that take place because of a high fructose diet versus the high glucose diet. So, all right, thank you so much for listening.